All right, net change. So first thing I want to do is I want to revisit velocity function. So let's talk about describing. Very much so. Okay. So let's say I have v of t. So this is my velocity equation. And maybe in this awesome equation, let's go with, how about 3t squared plus, oh my gosh, I got to use my brain today. Sorry, I'm there. Let's go with 6t minus right. How about 15? How about, let's try that again. How about 45? How about it? Yes. There we go. Okay. So if we're talking about velocity, we're talking about the linear motion, right? Then we are actually talking about whether it's moving right, moving left, whether it's stopping. And so what did we do with this back in chapter 4 and 5 in order to decide that? That is a great question. Well, thank you. Yes, thank you. We set it equal to 0, right? So in order to decide what the velocity was doing, we had to set this equal to 0. So that's what we're going to do. What grade was that? All right. So then what can I undistribute out of this beautiful thing? Take a 3 out, leaves us with t squared plus 2t minus 15. All right. Then what are we going to do? Good. All right. Negative 15 on top, 2 on the bottom. You're going to get 5 and negative 3. I agree. So we have t plus 5. You were just thinking ahead there. And t minus 3, because that means that our two values for t are negative 5 and 3. So then what did we do with these to determine what was going on either side of those? Which is what? The line thingy. Science table. All right. Let's throw a science table up there. Okay. All right, to the left of to this side of negative 5, we're going to plug negative 6 into our factored form here. So I have negative 6 plus 5 gives me a negative. Negative times negative is positive. Correct, so this is a positive. That means to this side it's doing what? Going up. Or moving right, depending on how you think about it. I agree. All right, so let's plug 0 into here. That gives me a positive times a negative, or a negative. So this is, okay, or it's going left, backwards. So then if I put like 10 in here, I get a positive times a positive is a positive. So what we said was we are moving forward or right. And we're going to say from negative infinity to negative 5 because I didn't put any bounds on this. Then we went left or backward from negative 5 to 3. And then, of course, we went back right from 3 to infinity. We do recall this now, right? Yes. So then where are the points where we're stopped and changing directions in? Good. Negative 5 and 3. I agree. So this now sounds familiar, right? Okay. So, well, you got to have the intervals, but yeah. So the first part of numbers 1 through 8, I think it is, you have to do this. You just got to set it equal to 0. Nice. Find your zeros, put it in a science table, and describe it. Okay, we're good with that, right? right, next thing I need to talk about is the word displacement. Mm-hmm. Your displacement is your change in position. All right, so your displacement is how much it's changed over that time, right? Which is the same as finding your position or doing the antiderivative. Yeah, right? All right, then the last thing we're going to talk about is where to find your final position. Final position equals your initial, wherever you're starting at, plus your displacement. Which makes sense, right? So wherever I start at, if I start at 3, I do my antiderivative, see how much I've changed. My final position is going to tell me when I take my initial 3 plus my displacement, it'll tell me where I end up. All right, so let's do an example. Example number 1. I didn't miss that. All right, we're going to start with 1 through 8. So first thing we're going to do is there are 3 parts to this. Part A, determine when the particle moving right and left. That's part A. Kind of what we just talked about, right? Part B, I'm going to ask that you find the particle's displacement. And then for part C, if the particles start at S of 0 equals 3, so this is your starting, where T is 0, so you're starting at 3, find, I think it says final position, sorry, final, I wanted to write it like the book did. S of 0 equals 3. It's an S. All right, so we're going to start with one super easy because I know you guys miss this stuff so much. Let's start with the 5 cosine of t from 0 to 2 pi. All right, so the first thing we have to do is figure out where our zeros are so we can do, or where it would be stopped so we can figure out exactly when it's moving right and left, right? So think about your unit circle. If I were to set this equal to 0, 5 cosine of t equals 0, I would divide by 5. I need to know where cosine is 0. Yes, it's pi over 2 and 3 pi over 2, yes. Correct. So we have pi over 2 and we have 3 pi over 2. All right, so then if we're going to determine when it's going right and left, what do you think we want to do next? Sounds like a plan. Too bad. All right, so you'll notice in my signs table, why did I put the 0 and the 2 pi there? Yes, exactly. Thank you, Alyssa. Those are the bounds, right?
Yo, what? Why are they using the 2 pi?
Because I wrote the bounds. Those were the bounds, so it's only happening one time around the circle. So, if I were to pick something between 0 and pi over 2, or in the first quadrant, is cosine positive or negative? Positive, very good. Then in the second quadrant between pi over 2 and 3 pi over 2, is cosine positive or negative? Negative. Oh, now between 3 pi over 2 and 2 pi, it is positive. Are we all good? So let's describe this then. That's where we're starting at.
Right from 0 to pi over 2.
Yes, it's going right. From 0 to pi over 2. Left from pi over 2 to 3 pi over 2. And then, of course, right from 3 pi over 2 to 2 pi. Now, why am I doing parentheses and not brackets?
Because it's not bounded.
Correct. It can equal those. Those are where it stopped, right? So it's not moving right or left at those points. So we cannot use brackets on them. They have to be parentheses. Okay? We're good with that part.
Good.
Talk about part B. Part B, to find the displacement. We're going to do the integral from 0 to 2 pi of 5 cosine of t dt. Nope.
And so everything was questions had 2 parts like this?
What?
All the questions from 1 to 8 had 2 parts like this?
They have 3 parts. We're going to get there. Yeah. They don't take long, though. All right. Antiderivative of 5 cosine t is 5 sine t. And we're going to do it from 0 to 2 pi. So we have 5 sine at 2 pi minus 5 sine at 0. Well, sine at 2 pi is what? Sine is your y value. It is 0. So this is 5 times 0, if I can get this to work, minus 5 times 0, because we came all the way back around, right? So really our displacement is 0 in this case. So part B is we ended up back where we started. So then for part C, when it wants the total distance, or your final position, you take the 3 that they started with and add your displacement. Well, we didn't go anywhere. So this equals 3. All right, so real quick before we keep going, I want to make a comparison using a graph real quick. Let me get this up here. Huh? Yeah, so we can talk about everything.
My baby's missed me.
Better check my mode, make sure I'm in radians, which I am. All right, so that was 5 cosine of x. And let's change the window. So we're going from 0 to 2 pi. All right, graph. All right, so you'll notice that it's above the x-axis from 0 to pi over 2. That's where we're going right. Then we're going left from pi over 2 to 3 pi over 2, because that's under the x-axis. And then from 3 pi over 2 to 2 pi, we're back above the x-axis. Now, why do you think this displacement was 0? Yeah, so they like cancel each other out, right? The peaks cancel out the what's underneath the x-axis and they cancel each other. So you actually end up where you started. Okay? Any question?
So is the displacement like the y? Or is that not a...
Your displacement, when you look at a graph, it's actually the area between the x-axis and your curve.
Okay.
So above the x-axis is positive, below the x-axis is negative, and in this case, they ended up canceling each other out. Right? All right. So, do you guys want another one from that first section?
I think that'd be okay.
I mean, that was a trig one. Whoops. We're good? All right. Well, then let's go to example number 2. All right, so I'm going to draw up here. I'm going to try and draw to the best of my capability. Start a line here. I'm going to go here at... So my first line is going to go from here to here. And then let's go out here. 2, 3, 4, 5. At 6, I'm going to go maybe down here. So my next line segment is going to go from there, crosses through 5, to where 6 is at 1. And then let's take it back up at 7. All right, so we have 3 line segments going on. All right, so we're going to do a couple things here. Part A, I want you to find where the particle is at the end of the trip. And then part B, we're going to talk about the total distance traveled. Does that have 2 L's in it? One. Just one. All right. Thank you for that assistance. All right, so when we're talking about where the particle is at the end of the trip, we're talking about the area under the curve. So this is straight lines or straight line segments, so we can do this by finding the area of each of those. Yes, exactly. So in this first one, my triangle, the area of this triangle, that is 1/2. The base is 1. The height is -2. What is the area of my first little triangle? How about -1? I like it. This is -1. Okay, let's do the area of this triangle. This is 1/2. The base, which is 1, 2, 3, 4, and the height is 2. The area of triangle number 2? About 4. I think that's a plan. And now we got to do the area for our last triangle. Our last triangle, we have 1/2. The base, which is 2, times the height, which is -1. I agree, it's -1, right? Everybody good? Okay. So now, if I'm talking about where the particle ends up at the trip, all I have to do is add those 3 things together.
2.
Okay, so for this one, I have -1 plus 4 plus -1. It equals 2. I agree. So it ended up at 2. And then when I talk about the total distance, when I talk about total distance, we have to take the absolute value of each section. So we're taking the absolute value of our first triangle plus the absolute value of our second triangle plus the absolute value of our third triangle. So what do we get here? 6. Absolutely. So that's the total you traveled, is 6. So, I mean, if you think about it, you went left 1, then right 4, then left 1. So you ended up at 2, right? But that total distance you traveled, you have to add them all together. This is the basis of today. So I really think,
We can handle it?
I think so.
I really think. Can I use
Yeah.
the bathroom? No.
All right, so let's try it. We'll see, because a lot of it's interpretation of what it is you're finding. And, of course, 1 through 8, got to get back into doing a little bit of integration. Okay, so I want to make sure that we're not putting too much on us. We got this, right? Okay. Yeah, go ahead.